In chapter 7, we are starting the study of stoichiometry. And stoichiometry is just a big word for something that is actually a very, very valuable and very necessary technique in chemistry. What we're doing is we're just learning how to calculate amounts, and we can then convert that to number of atoms or number of grams that we have of a certain chemical. And then we can apply that to chemical reactions to calculate how much we're going to make, how much we want to be able to make of a particular product. This is absolutely crucial in industry. It's crucial in any kind of research. And so stoichiometry is a skill that if you're going to really do anything in chemistry, you really have to master well. Now, you guys are probably already familiar with words like pair, a pair of shoes, or dozen for a dozen eggs. I know that not all countries sell eggs by the dozen, but in the United States we do tend to sell eggs by the dozen, which means you have 12. And so with those words, you know that if I have 2 pairs of shoes, I actually have a total of 4 shoes. If I have 3 dozen eggs, then I have 3 times 12 or 36 eggs. Well, the word mole, although normally you may think of a mole as a small furry creature, and they're really not very cute, even though all the cartoony type of pictures you see in chemistry books tend to show really cute moles. I've never actually seen a cute mole at all in my whole life. But the word mole, M-O-L-E, is a word just like pair or dozen. And it helps us to specify a specific amount of a chemical, whether it be an atom, an element, whether it be a compound, but it helps us specify exactly how much we have. And so a mole of something is 6.02 times 10 to the 23rd atoms if you have an element, or it will be 6.02 times 10 to the 23rd molecules if you have a compound. And we'll do some of both of those here in the next few days so you can see exactly how that works. Moles are kind of like a bridge. If you know moles, you can find number of atoms or number of molecules, and you can also find number of grams. So what we're going to start with here is learning how to take the number of moles and convert it to something else. So this is all a big conversion game right here at the beginning. So let's start with boron. You should have the papers with you that I sent that have all the sample problems for all the videos. So if you don't have that with you, you're going to want to stop the video and go get that so that you've got the sample problems that I'm working in so that you can write down what I'm doing. We're going to start with boron, and boron on your periodic table is up here. You'll need your periodic table as well, so if you don't have that, make sure you go find that. So if you look at boron, and if I have 1 mole of boron, then I will have 6.02 times 10 to the 23rd atoms of boron, because we're talking about an element. Also, the small number that you see there, 10.81, that is how many grams there are in 1 mole of boron. Okay, that is going to be called the molar mass. He doesn't actually use that term in your book, but it's a very commonly used term that you'll come across in other chemistry textbooks if you take chemistry, a more advanced version of chemistry somewhere else later on. So the molar mass is the mass of 1 mole of an element in grams. Okay, let's do another example. Let's look at argon. So argon is a noble gas, and it's over here in the far right-hand column, the third row down. 1 mole of argon is 6.02 times 10 to the 23rd atoms of argon. And if you look at the mass that's given on the periodic table, you should see 39.95. So it will be 39.95 grams of argon for 1 mole of argon. Now what I can do with that is I can take any of those 3 numbers, the number of moles, the number of grams, or the number of atoms, and I can turn those into conversion factors so that I can convert one type of measurement into another type of measurement. So we'll do a few examples here. We're going to start with magnesium. The first question on your sheet says, how many atoms are in 0.80 moles of magnesium? You're always going to take what they give you, the given, and you're going to put it over 1. So I'm going to take 0.80 moles of magnesium, and I'm going to put that over 1, okay? Then I need to come up with a conversion factor to get from moles into the number of atoms. And the way I'm going to do that is that since I have moles on the top, I need to put moles of magnesium on the bottom, and I'm looking for atoms of magnesium. So since that's what I'm looking for, that needs to go on the top. Well, what numbers are going to correspond with this? Well, 1 mole is always equal to 6.02 times 10 to the 23rd atoms. And so therefore, moles of magnesium will cancel out. And if you type this into your scientific calculator, and we've already talked before about how to put that into scientific notation, you're going to take 0.80 times 6.02 times 10 to the 23rd, and you should get an answer of 4.8 times 10 to the 23rd atoms of magnesium. Okay? 2 significant figures, since that's what I started with. Okay? The next question there says, how many grams are in 0.80 moles of magnesium? So again, I'm still starting with 0.80 moles of magnesium, but this time I need to go from moles of magnesium to grams of magnesium. Okay, what's the relationship here? Well, it's always going to be 1 mole, and then the number of grams of magnesium comes from the periodic table. And if you look at the periodic table, you will find that that is 24.31 grams. Again, looking at the periodic table, and that's where you're going to get that number from. I do want to make a point that in your textbook, the author seems to want you to take these molar masses out to 2 decimal places, out to the hundredths place. You will find other textbooks that don't expect you to take it out that far. Some of them will say it's okay to round it to 24. Some of them will take it to the tenths place. Because this is what the author of your textbook is doing, that's what I'll have you do as well. Go ahead and take this out to the hundredths place when you find that, but just be aware that, again, if you take the class, take chemistry in another context, the professor or the teacher might be perfectly happy with you rounding that a little bit closer. Okay, so moles here will cancel out. You'll take 0.8 times 24.31, and you will end up with 19 grams of magnesium. Okay, the next one says, this time we're going to start with 20 grams of chromium. Well, again, take the 20 grams of chromium and put it over 1. You always take your given and you put it over 1. So this time I need to get rid of grams of chromium, and I'm trying to find moles of chromium. So I know that I've got to set things up this way so that everything will cancel. In 1 mole of chromium, if you look at the periodic table, you will find that you have 52.00 grams of chromium. Again, find chromium on the periodic table and see what the mass is there. That's called the molar mass. So grams of chromium will cancel out. So in order to do this, you're going to take 20 divided by 52, and that's going to give you 0.385 moles of chromium. Okay. Next example there, if you have 2.46 times 10 to the 23rd atoms of sodium, 2.46 times 10 to the 23rd atoms of sodium. You always take what they give you and you put it over 1. What are they asking me to find? They're asking me how many moles I have. Well, I need to get rid of atoms of sodium, and I need to find moles of sodium. 1 mole is always equal to 6.02 times 10 to the 23rd atoms. So therefore atoms will cancel out. So you're going to take 2.46 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, and that will give you an answer of 0.409 moles of sodium. Okay, 3 significant figures, so that's what I started with. One more example problem here. If you have 36.5 grams of aluminum how many atoms do you have? Now, this is actually a two-step process. And so in your book, he will actually do it in two separate equations with two separate calculations. I like to put all this together into one because as long as my units all cancel out, I know that I've set it up right. So again, we'll start with, what was it, 36.5 grams of aluminum. That always goes over 1. You always take what they give you and you put it over 1. Now, I know that because moles is kind of the bridge, I know that I've got to get from grams of aluminum to moles of aluminum. And in 1 mole of aluminum, the periodic table tells me that it's going to be 26.98 grams of aluminum. So grams of aluminum will cancel out. But the question asked me for atoms. So I now have to take moles of aluminum and change it to atoms of aluminum. And in 1 mole, there are always 6.02 times 10 to the 23rd atoms. Okay, so once again, moles cancels out. And when you type this into your calculator, you can do it all in one fell swoop. You can take 36.5 times 6.02 times 10 to the 23rd divided by 26.98. Okay, just type it all in all at one time, and your final answer is going to be 8.14 times 10 to the 23rd atoms of aluminum. Okay, be aware that if you choose to do this all in one step and you do this all together, it may make your answers a slightly bit different of the answers that are in the answer key. It's not going to be off by very much. It may be off by, 1 decimal place or so, or it's not going to be exactly the same, and that's okay. It's a significant figure issue and a rounding issue that he gets because he rounds partway through and then he has to round again at the end. When you do it all in one fell swoop, again, you're going to have a slightly different answer, and there's nothing wrong with that. So today you're practicing changing grams to moles to number of atoms, and these are just for elements. And then in the next video, we'll talk about doing this for molecules.